ask people to come in. So we should be starting in about a minute or two. So. Yeah. Yes, yes, yes. Yeah, I actually also have it on here to that link. Everybody to the GenAI Collective Chicago chapter. The first, I suppose this is like for technical meetup, this is like the first one because our group is very grassroots at this point. And Jonathan, who's here, who's the one that is playing the harmonica, he's the head of the Chicago chapter. So we're going to start this and we'll introduce you to this organization a little bit too. So today's theme is Agentic in the Wild. And thank you to Jonathan for naming the event. Next week, too, in fact, we'll also have another event on June 5th, too, and that will be a mystery event, but it's called Agentic AI Unleashed. So because we have a lot of interest in agents and all of these talks, so that's why we're going to have more and more of these kind of meetups. So today's sponsor, let me quickly, I want to thank you all the sponsors here. So first is Vectorize, Chris Latimer, and he will be doing the talk. He's the CEO and the founder, co-founder of Vectorize. And then also Chris Bartholomew, but he's not here and he's based in Canada, right? Yeah. So, okay, and I used to work with them at Datastax too, by the way. So they're very deeply experienced, hands-on folks. So, and then we also have Microsoft Chicago, David. Where's David? David was here in a second. But anyway, if you see David, please thank him too, because every time when I call him, I said, David, I need a space, and he's always there to help. So that's why we can enjoy this space really nicely. So thank you again. When he comes in, I'm going to thank him again. So now we'll get to know a bit about who is the Gen AI Collective. We are a group that's based out of, that started about 2 years ago, or maybe Jonathan, now that you're in, I just realized, would you like to say a few words about Gen AI? I'll let you say a few words of introduction about Gen AI Collective. Yeah, okay. Yeah, sure.
Hi, so good to see you all. Back in November, I reached out to the GenAI Collective. I'd seen it growing for about 2 years in San Francisco and on the coast. San Francisco, Seattle, New York, DC, all these cities have these major events going on, 100, 200, 300 people. They continue to grow. We now see this internationally. It's like London, Paris, Bangalore, you name it, we're in every city around the world. So I reached out and I said, we'd love to see this in Chicago. We've got a lot of great people from both the business and technical side, but we don't necessarily have a place where they can all meet together and have really good conversations and sort of goal ideas. And so I said, we'd like to launch a chapter of the GenAI Club here, and they were super supportive of it. And we've got nothing but wonderful folks and members like Mary who support this. Eric, who's here as well. We've got Glenn, who is somewhere around here. But we've got a variety of events that are both technical and non-technical to speak to all kinds of folks. To that end, if you'd like to get involved, this is my brief pitch.
Yes.
We need more hands, more spaces, more sponsors. To that end, Mary, thank you for all you do on hand.
Thank you.
Thank you all for coming out. We appreciate you.
Thank you. Thank you so much, Jonathan. And I have to mention that Jonathan is a very, very good, is excellent coach too, because he hosted some of the meetups at his house like twice. And the food, oh my gosh, I'm still remembering your chicken dumpling soup. That's something I'm going after. But anyway, he's a great coach. So Okay, so call for volunteers. If you're interested in helping, yeah, we can always make use of the help too. So please reach us, myself, Jonathan, or Eric too. He's around here. So some code of conduct, I just wanted to kind of point out, it's just for all meetup groups too. We don't want any hatred. We are judgment free. We want you to be kind to one another and helpful and be proactive and also to be encouraging to one another, especially with this field that we're in. AI, machine learning is kind of growing by leaps and bounds. So we like everybody to be helping one another too. Some housekeeping information. So if you are interested and if you want to tell your friends who cannot be here and you want them to watch this, this is being live streamed to this YouTube channel. If you search for GenAI Collective, the YouTube channel, you can also find it there too. It's underneath the live kind of section too. And also, just a note, I'd like to remind you all, we really appreciate you coming. Right now, we're using Luma to notify all of the events to you. But we'd like to remind you if you can enter your full legal name, because very often, for example, like a place such as Microsoft here, it's got very strict building security. So we need to give them the list of attendees. And so when I have to go through that, if you don't have your full name, then I have to cross-reference all of the LinkedIn and all that. So that kind of like takes a bit of time, and we're just volunteers. So just like to remind you of that for next time. So
just to say that if you don't provide your information, you don't get in. If we don't know who you are, it's tough to find out who you are. So we had to say no to about 15 people who provided just a first name or no other information about themselves. Sure. We didn't quite know who they were or how to get them in the building.
Yeah, sure. Okay, thank you. Not all places require security, but there are some that do. So we like you to give us your full legal name. It's easier. Okay, some announcements. Next event will be next Thursday. As mentioned already, it is a mystery event from our mothership, the San Francisco one. So come here. We're just going to spend a few minutes making some interesting announcement. And then we're going to focus on an Agentic AI Unleashed events with more technical talks. So there will be like actually a panel, as well as like 2 talks by Programmers Inc., their company. And that's the link. You can always find us on Luma as well. If you search for GenAI, you can find our events. But I'd like to point out too, on June 8th, Sunday, we're going to participate in a tech walk too, and it will be up more on the north side, I think Lincoln Park, the location. So it should be fun too if you're interested. We're just gonna walk and be, very relaxed and talk about tech. So for about an hour and a half. And then on June 24th, we're going to have an event called the Future of Work, and it's more for folks, maybe if you're looking for employment or talking to areas, hiring companies too. So we're going to have companies such as McDonald's, and I think a couple of other big ones too will also be present too. So we encourage you to sign up for it if you're interested. Here, so now I get to the good part, which is our speaker from Denver, Chris Latimer. He's the founder and CEO of Vectorize. He'll be doing a talk. And then we also will have another demo talk after this by Michael Cunningham, the Chicago's very own Michael. Where are you? He's somewhere. Oh, yes, right there. Sorry. So he'll be also doing a demo talk. He's also the founder of Building AI Agents. And if you came to our Crew AI event that was in April, then he and I will collaborating on that one. So with that, I want to thank you very much and for coming. And then if you have any questions, please approach any one of us. And also this is our Luma link for the GenAI Collective too. So thank you. So now the stage is for Chris. Yeah.
Thank you.
All right. And we have this, and do you need this?
Yeah. Save my voice.
Yeah.
I've done so much talking today.
So this one is for you. Yeah. Okay. All right. Okay.
Start a little quiet, make sure I don't blow out anybody's eardrums here tonight. Yeah. Hey, everyone. Thanks for having me. First off, excited to be here. Chris Latimer. I am, as Mary said, founder, CEO of Vectorize. We are an AI data platform. And before that, I spent many, many years, multiple decades in software engineering, building out applications, building out cloud services at places like Google, at Apogee, eventually getting into vector databases at Datastax. And that's really where I learned all the things that could go wrong when you're building out AI applications. And so trying to make those go right and make that whole process easier is why we ended up building Vectorize. So our goals here, three main things. I want to talk about AI agents and what they are. There's a lot of different definitions of agents, so we'll kind of talk about the ones that I'm specifically referring to. We'll also look at the challenges that you'll run into as you're building agents, and then what can you actually do about those. And hopefully by the end of today's session, you'll get a good sense of pitfalls that you'll fall into if you're not careful, how to avoid them, and how to actually get your agents to do what you want them to do. So to start off, let's talk a little bit about what I mean by agents, because almost everything, if you look at marketers call everything an agent. Innate in workflows are agents. If you're on LinkedIn, I'm sure they call things agents there as well. But when I think about an agent, what I'm really talking about are things that have agency. How do we automate a task in such a way that your agent is able to think for itself and to accomplish whatever it is that you want that agent to set out to do? And so in order to do this, we need to think of an agent as having agency, not just a workflow that calls an LLM, although there's absolutely nothing wrong with building workflows that call LLMs. That's a little different than what I'm talking about here. They have some way of interacting with their environment. And usually for the things that we're working on in an enterprise setting, that means we need to retrieve data. We need to interact with operational systems. We need to retrieve knowledge to help the agent make sense of the user's request. And we wanted to do this in a semi-autonomous way, sometimes with a human in the loop, sometimes not, depending on the stakes that are involved. And I like to think about an agentic system in terms of its architecture. And I like to think about it in terms of this three-layered architecture, where we have at the bottom a reasoning layer. And the reasoning layer is what is going to decide on the next steps to take in order to accomplish whatever the goal is that the agent has, whether that is responding to a user, whether that's resolving a customer issue, whether that's booking a meeting. We want the agent to be able to figure out how to accomplish the task at hand. And in order to do that, the agent needs access to tools. And so we have a tool and retrieval layer. And then as developers, where we spend most of our time is here on this orchestration layer, where we're trying to figure out how do we connect the LLM to the tools and functions that it needs to be able to accomplish the task that we've given it to accomplish. Now, I thought I moved this slide. I hate that. Yeah, I'm going to come back to this slide. Oh, no, I didn't. Okay, never mind. But I have duplicates. Sorry, one second. Okay, I was here. I did have duplicates. Okay, so how do we connect the reasoning layer to the tool layer? And the main function that we have available to us via the LLMs is something called function calling. And for those of you who are really familiar with the space, been doing a bunch with the space, this may be obvious to you, but I talk to people on a weekly basis who are under the misconception that, like, hey, the function calling in an LLM is going to call the function for me. It's just going to make the call. It's going to handle sort of that interaction. But that's actually not how it works. LLMs don't have any way of directly calling your functions. And so the way that this works in practice is that when you're building your application and your user gives you some sort of input, instead of just passing that along to the model on its own, we need to tell the model what tools are available to it. And so we'll pass in the prompt and then generally the tools that are available. And then the model will come back and tell us, hey, of those functions that you gave me, and we'll tell the model, we'll usually give it some sort of setting here. It could be required. You must give me back a function call every time. You can decide whether or not it's a function call or don't use a function. The LLM will then hand back a function if appropriate. And then it's up to our application to actually make that function work. Once we've invoked that function and got the response back, we'll hand that with a conversation history to the LLM. It will then decide if the conversation is done or we should call another function. And this agentic loop here is really at the heart of all agentic systems. This is how the LLM is able to automate these processes using the tools that we give it at its disposal. So, where do things go wrong? Because at the surface, this seems fairly simple. And usually one of the things that that sort of early on in your time building out agents you may run into is that you say, well, you're the reasoning layer LLM. You should be able to figure this out. Here's a bunch of tools. Here's a complex task that I want you to do. Just go figure it out and call the things that you need to call in the order you need to call them and let me know when you're done. I'm done. It's up to you from here. And the LLM will happily take that request. And it will hand back about what you would expect it to hand back, which is usually not what you wanted it to do. It'll hand back something that's pretty far off the mark. And unfortunately for us all, the MCP doesn't actually solve this. So MCP is fun new technology that's very promising, but it really just wraps the server around the same problem if you use the same approach. So why do things go wrong in agents and where do things go off the rails? So generally there's sort of three areas that we want to take a look at. The first is data access. And so agents are only as good as the data that you give them. And if the agent doesn't have the data required to complete its task, it's going to be somewhat helpless. So figuring out how we're able to expose in that tool layer the data that the agent needs, the retrieval functions that the agent needs to complete the task is incredibly important. Likewise, we'll have this tendency, or we'll see folks do this quite a bit, where we'll start off with an agent that's just too big and too complex. And so thinking about how we break down the bigger problems that an agent is trying to tackle into smaller steps, build specialized agents that are able to solve those individual capabilities. We'll see how that can help us quite a bit in terms of getting agents to do what we want. And then likewise, we still have to think about prompting. At the end of the day with LLMs, so much comes down to constructing a prompt in the right way so that the LLM is going to hand you back the exact answer that you want and interpret the task at hand in the right way. And all of these become critically important in terms of getting your agents to work right. Now, I personally like to think about this as how do we apply the Unix philosophy to agents? And if you think about the Unix philosophy, it's worked out very well, still as relevant today as it was 40 plus years ago when it was first developed. And it's the idea of taking agents and making agents that do one thing well, knowing that the output of one agent is going to often become the input to another agent. And so one of the frameworks that came out that I think illustrates this concept really well in sort of a simple way, even though they position it as never use this in production, is OpenAI Swarm. And I was playing around with that probably 6 months ago when it came out, maybe a little bit more now. And thinking to myself, like, wow, this is so simple. Like they've essentially built this mechanism. Here's how we hand off, they've got a couple good examples of, a customer support request comes in. Do I hand it off to the Spanish agent, to the English agent, and then hand it back? And it was like, this is beautiful in its simplicity. And so, I had the weekend free and I was like, I'll make this work with not just OpenAI, but Gemini and Anthropic and Grok as well. And then I suddenly realized why so many of these frameworks are so big and bloated. And it was just because all of the complexity that got added to make these things work with different LLMs was where all the code went. And the actual logic was actually like brilliantly simple. So check out OpenAI Swarm if you want like a really simple example of sort of this pattern. Now, breaking things out have advantages. Just like we would have in the world of, say, microservices, we create these agents in such a way that they are easier to test. They're easier for us to reuse across different applications. And because we have a more focused scope that we want this agent to be able to solve, it becomes easier for us to test, and it minimizes the things that the agent can mess up. Really, I don't see a ton of disadvantages to doing things this way, unless you bring in a framework and then you start dealing with the framework complexity. Nothing against frameworks, but I just don't want to maintain one personally. Now, when we start to get into the idea of data access patterns, this is where we need to think about generally two types of data. We're going to have operational data that we need to interact with, and we're going to have knowledge that we need to interact with. The structured data, the operational data, is generally more straightforward because if you go to any enterprise, we generally have solid API management, we have REST APIs, we have different ways of building out, we have decades before doing things like SOA. And so we know how to interact with our operational data, we know how to query databases. As we start getting into things that are more unstructured data, documents, conversation histories, meeting transcripts, those type of things, building out AI that is going to be able to find the right pieces of data in a sea of unstructured data becomes trickier. And this is where patterns like retrieval augmented generation have become really popular in the last year. But RAG, as useful as it is, has limitations. There are things that semantic search is going to be able to solve for and things that it's not going to be able to solve for. And this is where we see more and more folks that are investing in agentic RAG. So how can I now take this structured representation of my unstructured data, build search indexes in such a way that the LLM can very precisely focus in on the parts that it needs to be able to solve the task, and to be able to do that in a very reliable way. And generally, this is where we start to look at ideas like RAG pipelines. And so from a RAG pipeline perspective, we start thinking about sort of the different things that we need to do in that processing of unstructured data, starting with ingestion, pulling data in from files, from knowledge bases, from SaaS platforms, running it through an extraction process. If you've worked with PDFs, you know how surprisingly hard it is to work with a PDF. You would think that you would just open it up and pull the data that you want out, and nope, it's actually more in the world that it's more the way printers think about the world than the way humans think about the world. And so if you want to extract a table or you want to be able to extract things that are in multiple columns, it turns out that's quite a bit trickier. Likewise, chunking, as you're looking through a text document, figuring out where do I break chunks, the LLM generally doesn't need a whole bunch of irrelevant information. So how do we optimize that chunking process? And then ultimately, when we do the extraction, we also want to think about now, how do we take the unstructured version of this data, turn it into a structured representation? And we'll go through a demo here coming up where I'll show you sort of exactly how we do this and what that process looks like. And we'll see how kind of vanilla RAG is going to compare to this agentic RAG and the improvements that we're going to see in those two different approaches. Now, when I say agentic RAG, what I mean is when we think back to that architecture, we had the tool layer, we had the retrieval layer, the tool/retrieval layer, we had the reasoning layer and our orchestration layer. In the retrieval layer, one of the things that you can do is you can help the LLM make a good decision in terms of what retrieval function to call. And one of the best things that I've seen work here is to curate a set of retrieval functions that the LLM can use. So for example, we'll look here at a bunch of data sheets. And so I'll show you a demo that's based on a customer I was working with. This customer was in the semiconductor space. They make a lot of integrated circuits. Those circuits are things like op amps and comparators and amplifiers and things like that. And they have a bunch of data sheets for these things. And so when a distributor comes to them and says, hey, I don't really understand the electrical engineering aspect of this, but I know that I have a customer that needs to order 10,000 op amps and you've got a bunch of them and I don't know which one is comparable to this Texas Instrument part. They wanted to be able to do things like, well, let's look by op amps by manufacturer against Texas Instruments. And let's find things that have the specs that we need, and to be able to pull back the information that now is able to automate a lot of that, that distributor's job and the salesperson's job that would generally go and take a day to get back to the distributor. Now we can get back to them in, a half hour, however long it takes. And a lot of that is thanks to this agentic layer where we're able to build out a retrieval layer that the LLM can understand and find the data that it needs. So that's a lot of talk. Let's maybe take a look here and show you how this works. And so for that, I'm going to go into the Vectorize platform. And so within Vectorize, Vectorize is essentially the agentic data layer for agents, for chat conversational AIs and so forth. And the main sort of meat of the product is here in what we call a RAG pipeline. And so in a RAG pipeline, what we'll typically have is we'll have some sort of source. And so our source connector can be things like S3 or knowledge bases that we have. We can upload files. If you're doing, somebody earlier was talking about kind of an agentic project manager, you can pull in things like Fireflies and your issues from GitHub, whatever it is that you're building out. In this case, I've got a bunch of the data sheets that I was mentioning before. Data sheets that I was mentioning before, and those data sheets essentially look something like this, where we have information about like what type of product is it, what are the applications, and then a lot of technical details about this component, the pin diagrams, what pin is the voltage on, what are the operating temperatures, things like this. And what we wanted to do is to say, not just that I want to have sort of basic retrieval augmented generation on top of this data, but I want to take a more agentic approach. And so what we can do is I'll start off by kind of showing one simple example. So we're going to import a bunch of these documents here. There's about 8 different data sheets that are on here. We're going to send this through our extractor and chunker. It's going to extract all the text out. It's going to chunk this up based on this paragraph chunking strategy. We're then going to use OpenAI v3 small model to perform the embedding, and then we're going to push this into a vector database. And so let's deploy this now. Sorry, what? I'm sorry, I can't hear you. Oh, there's no light mode. Sorry, we could turn the lights down maybe. Is there a light switch in here to see this better? There we go. Is it better? Yeah, thanks for letting me know. So what this will do is this will start to deploy out the pipeline, and this will start processing all of our pages, all of the pages that we have in these documents. And so as this works, it's going to discover the pages. We can look at each individual doc here, see where it's at in the processing pipeline. Some of these are still extracting. Some of these have started to chunk. And eventually they'll all end up over in the vector database. As they do, what we'll see is that we can interact with these in our RAG sandbox. And so, yeah, these are starting to get written now to the vector database. So as these get written, we have this tab at the top is the RAG sandbox. The RAG sandbox is now how we can test end-to-end our RAG flow. And so we can test here different prompts. We can test different system behavior, and we have a chat interface. So we can come in now and say, for example, what operational amplifiers, do you have? And this will probably get relevant results because there are a bunch of things in here about operational amplifiers. And so we'll get back, we have several operational amplifiers, but we don't know if this is a comprehensive list. We only have sort of a partial list of the first 5 things that came back from the vector database. And so what we'd like to do is we'd like to get improved retrieval. We'd like to power this more into an agentic RAG solution. And to do that, what we can do is we can leverage a schema. And so within Vectorize, I'm going to use this schema right here. One of the cool things that you can do within your pipeline is you can say, anytime you see a document of a certain type, I want you to classify it as that type. And there's certain fields that I want you to pull out. And so in this case, I'm going to call this, I've done this a few times, so I had to come up with new names. We're going to now say, here are the things I care about and how I want my agent to be able to interact with this data. I've got component types. So if I want to search just by op amps or comparators, I want to be able to do that. I want to be able to pull out the features because the LLM will care about the features. I might want to search by temperature range that this thing can operate at, and so forth. And we can customize this using any sort of valid JSON schema to describe the data in the fields that we want to pull out. Once we save this, this will now be available directly into our RAG pipeline. And so if I come back here again and I'll create another, oops, wrong place, create another RAG pipeline, I can use the same source again. We'll pull in these same data sheets. But this time, because these are fairly complex, I'll use our iris extractor. And this is a finely tuned vision model that's going to be able to handle tables and more advanced structures and things like that. And we can also turn on this metadata extraction. And so with metadata extraction, I can say, any of the types of data that I have, in this case, I'm just going to use the one because we just have data sheets. I'm going to turn that on here. And now anytime we see one of the data sheets, anytime a document matches the schema, we're going to extract that data. And I'll just use the same thing here and deploy it. But because that's going to take a minute for it to run through, I've got one that's already created. So I'll show you sort of the net result of it over here. Agentic data sheets. So this is the same 8 documents that we looked at before. And if I come in here to this documents view, what I can do is I can verify that within each of the chunks that got created for this document, we're going to see that metadata. So what are the applications? This is like what type of component do we have here? Probably an op amp. Okay, it's an op amp. It's good for medical instrumentation, precision voltages, reference buffers, all these type of things. And we get sort of the pieces that we want to extract out of here as well. Now, I have kind of two applications that I've wired up here. So the first is basic RAG. So this is just no agentic processing at all. This is just, I'm going to do semantic search, and I'm going to get data back from the vector database and hand it to the LLM. And so I can ask some sort of questions here, like, what op amps can operate at 1.5 volts? And so this is something where semantic search will generally find things that will tell us what voltages something operates at, because its voltage is similar, 1.5 volts is similar to 2 volts and 3 volts. And so, but it's coming back and telling us, hey, here's one, it operates at 3 volts. But that's not what I asked. I wanted one that operates at 1.5 volts. So what I have here is I have an agentic version of this. And the agentic version of this, the way that it works is that I've wired up a number of functions. And so I've told the LLM in that tool layer, here are the tools you have available. You can search by part number, you can search by component type, you can search by specification, or search all of the documents. And it's up to you to figure out how to respond to the user by retrieving the data that you need to be able to answer this question. And so over here, if we say the same thing to the agentic version, and we say, what op amps can operate at 1.5 volts? And we make this request. Now our components should go out and do a retrieval function. Oh no, I forgot to pray to the demo gods before the talk. Never want to forget that. Ta-da! No. So we should. What should be happening? What should be happening if this was working the way that I was hoping it was going to work, is that we would see the function calls here happening to our retrieval functions. But instead, what's happening is nothing. It did find the question, so it's working. It's doing something, but it's not doing the thing that we wanted it to do. All right, let me ask a different question. What component types do you carry? Okay. Didn't call a function, but at least it did something. Oh well, that's too bad. It's the way demos go, though. Oh no, here we go. We did get a function. It did the function call. Delayed for some reason, but it did get there. What we see here is, so we said, what operational amplifiers do we have? And it says, I'm going to search by component. And so it's just going to now pull back the data about operational amplifiers, take that information, and come back. And if we say, what op amps can operate, what op-amps, do you recommend for low power use cases? We'll see if it'll make a call this time or not. Well, normally what it will do is it'll pick from these functions that we provide here and then decide what the best route should be to get to the data that it needs, whether that's going across all the documents. If this is a more general question, I'm looking for kind of a needle in the haystack sort of application, or if I'm looking at specific retrieval functions here to be able to get to the answer that we need. And for whatever reason, it looks like it's being a bit temperamental here in my Next.js application. I'm not sure why. You might have a timeout or something, but this is kind of the flow, right? This is how we are able to think about the use cases that we want our agent to be able to support. Think about the data that it needs, do the deconstruction into these different micro agents, and ultimately get back to an agent that's going to perform the way that we want, because we've given it better data to be able to support the requirements that it has. And so that's some of the lessons that we've learned, some of the techniques that we've seen work really well to be able to get better overall performance from agents. And if any of you want to talk more about this, feel free to reach out to me. There's my email, my LinkedIn. I am on Twitter sometimes. And as well, if you have a project, something like that, where you're working on agents, you want to talk more one-on-one, this goes in my Calendly, so feel free to book some time. And I'd be happy to chat with you more one-on-one. And with that, do we have time for a couple questions before we move on to Michael? Where's Mary? I think we do. Wait, how long is your talk, Michael? You've got... Oh, okay, so, all right, cool. So we've got time. I'm happy to take any questions if anybody has anything.
Mind if I ask about your competitor landscape? Who else would work like this?
Competitor landscape, a lot of do-it-yourself is by far the #1 competitor that we see. A lot of folks will kind of get into, they'll get into like the beginnings of a project. Oops, there it was. Right, and they start to look at this and say, okay, hey, this doesn't seem that complex, because all I'm going to do is I can do extraction and chunking and embedding, and yeah, I can query my vector database. And usually what happens is you kind of go down that path and realize, oh, this is actually a little bit harder than I thought. I'm getting back really poor answers to my agent's not responding the way I want. My conversational AI is still hallucinating. And why is that happening? Well, that can happen for a number of reasons. It could happen because there's something going on with extraction, or I picked the wrong embedding model, I chunked my documents the wrong way. It could be because my RAG pipeline is not working that well. My data, I didn't think about how I'm going to update the data. I got my one-time load into the vector database fine, but that source system changes, and now things are not working as well. So a lot of times this is where people find us, is that they kind of go down this path and say, yeah, the V1 was pretty easy. And then I have a whole lot of projects in my backlog and I have to do this for. Suddenly it's tedious work, and debugging these things is not that fun. And building things is way more fun than maintaining things. And so that's when you can hand off that maintaining of all of this infrastructure to Vectorize, and we don't mind doing it. Yeah, right here.
Yeah. Plans to bring in automated evaluation
Yeah, we do actually. So there's a whole section in the product that is basically end-to-end testing and eval. So we have to start down here. So we have I didn't show it here, but we have a feature called RAG evaluation. What that does is it lets you start with a sample of your data and test different embedding models, different chunking strategies, different retrieval settings against your vector database to see what is going to give me the best performance, and best performance in terms of relevancy, in terms of retrieval, and in terms of what we call NDCG, or normalized discounted cumulative gain. And so we use a lot of information retrieval metrics to help you figure out up front what's going to work best. And then from a performance monitoring standpoint, as you've built out your pipelines and you're doing retrieval against them, you want to see kind of how your relevancy is trending over time. So if people are asking questions, you have blind spots in your data, we're able to surface that, and so you're able to kind of build this virtuous cycle within your data platform to be able to kind of continuously improve.
Valuation framework, or making them custom?
No, there were no good open source options when we started, and we built this out. Like since then, Ragas kind of came and went. Amazon came out with a pretty good open source project a while ago, but we haven't integrated that into the solution. Oh yes, I'll come back to you.
I'm curious, just across your customer base, who's the persona is using doing this? Are you seeing full stack, agentic analysts that are running both building the agents and the RAG systems supporting it, or different teams? And then also, who's a persona that you sell to? Curious, it's also new, like how you go to market.
Yeah, so the question is, who's the persona that Vectorize is for, and kind of who do we sell to? Who gets the value out of this? So it's interesting. It's interesting because one of the topics that Mary had on the slide that she was showing was sort of the future of work, and I think that's a big topic as you think about software development and sort of this. We see what I believe is the first hints of AI engineers like ruling the world. And I thought what I thought was going to happen with an AI engineer is I thought you're going to be a data scientist or you're going to be an ML engineer and you're going to sort of move to this new world of an AI engineer. And what I actually see happening is people who are on the business side, like the business analysts, the people who are like technical enough to be dangerous, are now the ones that are finding these tools like N8N, like Lovable, like those type of tools, realizing these tools are great at workflow and kind of building the V1 application. They're not very good at the data engineering. But Vectorize, because we build it to be so easy to use, they find like, oh, I can do, you have created guardrails here that allow me to get really good results without having to be a data scientist, without having to understand like what's a dimension in an embedding model. And so we tend to find a lot of those folks are the ones that are coming to the product. And then on the enterprise side, it's still a lot of folks that are doing like more traditional development, folks that just have a big backlog of AI projects. Oh, sorry, there's a question here and then over there.
It's like LLMs are like increasing the context window.
Yeah.
And they seem to be doing good in like the needle in the haystack problem. How do you see like when to use RAG and when just to use the context window?
Yeah. So the question asked very nicely is RAG dead because context windows are big? And to me the answer to that question is no. For kind of one reason. I feel like we all intuitively realize that just because like our workstations have more memory and bigger hard drives, we've never once thought to ourselves, well, I just want to return the entire database to the application every time. Because that's just kind of just obviously doesn't make sense. Like the performance doesn't make sense, the network overhead doesn't make sense. And I think the same is true for these context windows. There are some cases where it's convenient. I want to chat with my docs, and I have, I have like 3 or 4 PDFs. Throw those into the context window. That's going to work just fine for you. In terms of like an ongoing solution to the data retrieval problem, I just don't see that ever being the right solution. We just never want to pull that much data back. And the LLMs, even though they're good at needle in the haystack, anybody who's ever gone through a ChatGPT conversation that's lasted more than maybe 20 cycles through, that quality kind of goes down pretty quick at a certain point. It starts getting really confused. And when you push too much information to the context window and expect the LLM to make sense of it, the same thing happens. So if they get really good at that, maybe like we'll see RAG kind of fall off. The other thing is I would also say, I think there's a distinction that like we need to make between vector databases and vector search and semantic search and RAG, because I think RAG is a technology just literally looking at the words retrieval, augmented generation. Even if we're retrieving by grabbing docs, I think that pattern is here to stay forever. Will vector databases always be the thing? Maybe, maybe not. Will knowledge graph take over? Could be. There's a bunch of downsides to knowledge graph. But I think we'll just see sort of a continuous refinement of how do we get the LLM the data that it needs. And I think that problem is one that's, not even solved yet. We'll be here for a long time. Yeah, Patrick. Oh, sorry.
Oh, sorry. Can you talk about security a little bit? Like, so example, if you're working on a project for a client and they want you to create some sort of rack type of system, but they want to make sure that their information is secure. Maybe it's a law firm, maybe it's any other type of organization, healthcare, something like that. Do you take the data? Do you save the data, or do you have certain compliance guardrails in place to help with that?
Yeah, so the question is about security. And so if I'm building an application, the example is for a law firm, and I need to think about different parts of security. I need to think about compliance. I need to think about privacy. And I would say, in general, we need to think about all the things we typically think about from the network on up to the application layer. Um, so there's a few ways to handle this. So there's kind of an RBAC question. So how do I make sure people only get access to the things that they want to get access to when I loaded a vector database, full of data? Um, that's a place where metadata can also help, because we can now say, what role should you have to be able to access this? And we can do filtering only by the things that people should have access to. You'll find that there are other integration points we could use for things like for example, Google has the data loss prevention API, right? So if we want to plug into that pipeline to be able to say, let's scrub out any PII that we have in here, we can do that as well. In terms of compliance, that comes down to that comes out of compliance. So, that's where we look to, like, are you SOC 2 compliant? If you're dealing with the medical world, are you HIPAA compliant? And making sure you've got sort of all those base controls that are there. And then, of course, there's additional things you can do depending on your use case. Maybe you need to keep everything completely on-prem. You can always look at using sort of the retrieval with like a local model like Llama 4. Vectorize, we don't really care whether we offer a vector database built in, but by default, you bring your own vector database. So we can also just write to a database. We handle the processing, and then everything else from the whole LLM and the retrieval side kind of stays local, and you can manage that as you see fit. Right here.
Outside of research, search, retrieval, what other use cases do you see agent protocols? Times I try to do agent stuff, I just find that code function or code workflow, and then just call that function rather than letting the agent figure that out.
Yeah. So the question is, like, basically, like, where are agents? Like, where's the sweet spot for agent that's not really just me writing a workflow? Um, well, I think it is. I think anytime there's a workflow, right? I think you can have an agent workflow, or you can have sort of a step by step. And I think the problem we have right now is that it's easier to code the workflow when you know what the workflow should be, and a lot of times when you know what it should be, it's we just get frustrated because the agent's not sort of doing what you want. Um, like I think the most the most popular cases for agents right now are things that are totally outside the realm. Your robot vacuum is an agent, right? It's figuring out like where to go on the floor, and things where you do need that autonomy. Most of the times, we don't really want our agents to be completely autonomous at this point. You don't want the agent on the fly deciding, should a customer get a refund or not? Should we let them cancel their plan or not if they are on a contract with us? So I think there's still a whole lot of human in the loop things. And as long as our business processes are geared towards that, um, I think it'll be a while before we see them really kind of taking over. Software development, I think, is probably where we're seeing the biggest leaps and bounds right now. Tools like Replit, Cursor, things like that are operating in agentic mode are probably like the most advanced that I see. Yes.
Cases,
Mhm.
especially compared to use cases the main team is now serving for. And I'm working with the developers who's using primarily using the main team, and I think what I've seen so far is a really good at customizing the pipeline, right? But for this one, I can see that a lot of parts are like very much like operationalized. So do you think that is actually good for non-technical people, or who are the main user person in your
Yeah. So the question is, who are the main users? Yeah. Well, so I think no, it's not just non-technical people. I think non-technical people have gravitated to the product because it is easy to use, and you don't need to be an expert in all of these things. But technical folks, like they appreciate different parts. So the part that a more technical team appreciates is when you start to get into the operationalization of the platform. So like our data, so our data engineering that we have built is on top of a technology called Apache Pulsar. And we use Pulsar because, well, my co-founder and I spent about 3 years building out a service on Pulsar. But we chose Pulsar because it's such a good technology for resilient pipelines with high deliverability guarantees. So we wanted to make sure that if any change happens in a source system, you can rest assured that that change is going to make its way into your vector database. And so you'll never have stale data. Right. So usually it's kind of an 80-20 proposition with a lot of these tools. Do you want to get like 80% of the way there? And for like non-mission critical things, that's probably okay. If you need to productionalize the solution and make sure it's resilient to like even a data center going down and is still able to process your messages, that's where we kind of then get a new appreciation from the technical folks in terms of how that all plays out. All right, let me go down to the side of the room. Good question. Yes.
How'd you build your agents? What's your tech stack?
My tech stack here is Node.js. It's built on top of the from Vercel. It's called the AI SDK, which is kind of like Next.js with a more agentic layer in there, which I really like, and I like it, but mostly because I've done a lot of development on single-page apps and JavaScript applications, and it's just like a really natural sort of like transition over to there. I never got that deeply into like LangChain. I played around with it a bit, and I still am to a certain degree, a little bit perplexed by I've never found myself like, wow, I really need like another framework to like sit here and help me. More like maybe there are things that it does you guys appreciate that I don't know. That was one of the things at the beginning. No judgment, right? So I say that not in judgment at all. But I say that just in terms of like my personal experience, like I've never seen it. But I really like the Vercel stuff, and I've had a really good experience using it. All right, well, I will be around afterwards too. So if you have any more questions you think of between now and then, do feel free to come chat with me. And up next, we have Michael, and he's going to give us another great presentation on AI agents.
And go through the whole green room up here, huh?
Passing of the torch. All right. Okay, I've got two. I've got this one for you, and I got this one for you. Oh, you got another one? Okay.
Okay. Is that the clip on my shirt?
Okay.
Does that sound good? Awesome. And we're live. All right. It's great to be here. Thank you to Mary. Where's Mary? Oh, well, thank you to Mary, who is not here at the moment, for bringing me here to speak, and to Jonathan as well. I actually, at a recent event that I co-hosted here with Mary, I called her the queen of the Chicago AI meetup scene, and I've been seeing that nickname catch on online, and so I'm totally going to claim credit for that. But it is totally well deserved. She is the queen of Chicago AI. So really grateful to her for bringing me here to speak, and obviously thank you to Chris for introducing me, Microsoft as well for hosting putting on the event. So, I'm Michael Cunningham. I am the founder of something called Building AI Agents, which I'll talk about in a minute. So, I actually grew up here in Illinois. I was actually born and raised down in Urbana. So, does anyone here go to University of Illinois? And show of hands. I. There we go. You stole my act. I was about to do that, but yeah, you jumped the gun. So went to University of Illinois, got my bachelor's there, and then master's at University of Wisconsin, and then came back here to Chicago. So I actually work at AbbVie, which is a big drug company in the Chicago area, as a machine learning engineer. So that's my day job. But on the side, I write, as I said, a newsletter called Building AI Agents to kind of help people stay in the loop on what's going on in Agentic AI, and I'll speak a little bit more about that in a minute. And one thing that I really wanted to cover in this talk today, obviously we have heard a lot about like AI agents, what they are. We had a great demo earlier, but one thing that I don't think really gets covered as much is like how this field actually came about, right? Like the history of it. And I think that's really fascinating. So I want to talk about that a little bit, and then also just to give a quick demo of an agent that you guys can actually build, or that I have a template of that I'll share with you that you can very easily adapt to whatever kind of simple use cases you want. It's actually very simple, but very powerful. So to kind of launch into the history of the AI agent fields, this really goes back to the rise of large language models in the kind of early to, I would say, mid to late 2010s. So there was this process of kind of discovering that this very simple next token prediction task was actually could actually lead to some really interesting emergent properties, right? You wouldn't intuitively think that just predicting the next word in a sequence of tokens, or the next token, would actually lead to something that was kind of like human intelligence. I mean, obviously, it's very hotly debated whether this truly is human intelligence or human-like intelligence, but certainly it has taken us very far towards actually useful applications. So late 2010s, people start to realize that this can be done. And really what I would say brought this into sharp relief for the tech world was the release of GPT-3, right? So OpenAI in May 2020 releases GPT-3. This is a model that is an order of magnitude bigger than anything that had ever come before. And they discovered that just scaling these models up actually results in some real intelligence, right? And so that really, in the tech world, everyone was talking about this in 2020, 2021, 2022. But it wasn't really until November 22 that you see the broader world kind of catch on to this, right? So obviously, everyone remembers ChatGPT comes out, and that just like all of a sudden, everyone's talking about LLMs, everyone's using them, and so ChatGPT was kind of the moment when this really became, it came into the public eye. Now, ChatGPT, obviously, as the name suggests, it was a chatbot. Chatbots can do some cool things like answering simple questions, but they can't really take actions, hold long-term memory, access data, access other resources, plan ahead. All of these are the kind of things that you actually need in order to do really economically useful tasks, right? If we were to ever have something that is like AGI, that would require all of those kind of capabilities in order to really be useful. Now, one cool thing that you can do with chatbots is you can give them a script, a fake script about the limitations of chatbots, and they can have that conversation with you. So that is a pretty cool capability they have. Now, what really started to change that and kind of build out the capabilities of these models is tool use. So this goes back to the Toolformer paper, which came out in February of 23. And basically what this means is that instead of just, you're talking to the model and it's just generating text tokens, you can actually give it access to coded tools. So for example, if you ask like, what is the weather like in Tokyo? If you just ask a chatbot that, it's going to either hallucinate an answer, or if it's honest, quote unquote honest, it's just going to say, I have no idea. But if you actually give it a coded function that allows it to do a web search that actually looks up the weather in a given city, it can say, okay, get weather for Tokyo. There's a temperature, precipitation. Oh, okay. And then it can answer that question with that context, right? It's a cool and rainy day. Maybe you want to bring an umbrella. Now, once that capability is in place to basically augment an LLM with any tool you can put into code, that really kind of opens up, you might say, like Pandora's toolbox, just because anything that you can put in code, now an LLM that can have it as its capabilities, and you can put just about anything in code, right? So that can be files, that can be data, that can be memory, that can be actually writing and then executing code. And that can even be other LLMs, right? If you can augment an LLM with anything that you can put in code, what is one thing that you can put in code? LLM calls, right? And so this kind of gets to the genesis of these sort of multi-agent systems, where instead of just one LLM agent, or you actually have several LLM agents or LLM chatbots, whatever kind of system you have, talking to each other, calling each other, being able to take advantage of each other's capabilities, right? Now, this AI agent field, I would say, really was launched with the release of AutoGPT in March of 2023. So before that, GPT 3.5, which was the model that powered ChatGPT, it was okay, but it wasn't good enough to actually embody the kind of intelligence you need for an agentic system. It was, it would hallucinate all the time. It would come up with nonsense answers. It wasn't very good at tool calling. In fact, I don't think it actually had tool calling capability at all. I think that was introduced with GPT-4. But so GPT-4 comes out, and now all of a sudden we have a model that is more intelligent than anything that had come before, and people immediately start using it for these kind of agents. So the way this works, and the first agent really was AutoGPT. There were a couple of others that came out around the same time, but I would say AutoGPT is kind of the canonical sort of first agent that really caught a lot of attention. So the way it works, user would give the agent a task. That task gets put into a queue and then broken down into subtasks that are necessary to complete in order to kind of complete the main task. That goes to an execution agent, and that that agent can take advantage of memory, right? So it's writing to memory, reading from memory, and this whole system, even it was not particularly effective. Honestly, it was still kind of a rickety machine that couldn't do much useful stuff. But like, so was the Wright Flyer, right? And so just because it itself was not useful, it really did set off this chain reaction of innovation that brought incredibly powerful systems that we have today. So now, as was alluded to in the previous talk, like there's a ton of debate over what an agent actually is, right? You go anywhere online, look on AI agents, everyone's arguing about, what is an agent, what is an agent, what is an agent. So the best definition that I've seen that I really like was given by Harrison Chase, who's the CEO of LangChain. LangChain's pretty cool. I'm honestly not a huge fan of their framework. I think LangGraph is a little bit better, but they put on this cool conference that I actually went to last week, the AI agent conference. So, and Harrison Chase is a super smart guy. So his definition of an AI agent, he says, an AI agent is a system that uses an LLM to determine the control flow of an application, right? So all software up to this point was just deterministic, instantiated in code, right? A, B, C, and the whole control flow of the application is dictated by pre-written code, right? But what AI agents then allowed is actual systems that adapt on the fly, how they operate using the intelligence embodied in an LLM. And so that opens up this whole new world of applications that are actually capable of sort of operating more intelligently than just sort of dumb hard code, right? Now, another way of putting this is that in a chatbot, the LLM is talking to you, whereas in an agent, the LLM is talking to the computer. Right? So it's actually sending instructions to the computer as to how to execute the program. But the LLM can also be talking to you, right? The best agents are actually interactive ones. And I will give a demonstration of one. So this is something that I kind of quickly put together called Easy Agent. I'm very creative with the names, but basically what this is intended to be is sort of almost the simplest possible agent, and just kind of a template that anyone can take and sub in their own functions and use it for their own purposes. It is intended to actually be able to do useful work, but it's also intended to be very easily comprehensible, easily modifiable, and so you can use it for essentially whatever you want, but it's easy to use off the shelf. And this is also instantiated right now entirely in a Jupyter notebook, so that you can just run it like you would run any other kind of simple educational or demo program. But obviously, feel free to take it and modify it however you wish if you want to use it. So first thing we would install OpenAI. That's already been done. Go ahead and import some libraries. And really the only code that lives outside of this notebook is this utils file, where we just have a couple of utility functions that take in the functions that we're giving to the agent, and then annotates them so that the agent can actually see how to use them. And you probably won't need to modify any of this. So I'll go ahead, import those utils, import everything we need, and then we have our configuration, right? So we're actually, this agent, as it's currently set up, is capable of sending emails. I trust you all, but I'm still not going to put my my email password up on the screen. I'm sorry. So, so we get email password. Define a couple of parameters. Here we're using OpenAI GPT 4.1, but you can sub in whatever language, whatever LLM you want, and use if you want to, you can adapt the code for Anthropic, right? Claude, Google Gemini, whatever you want. Now, these functions are actually what gives the agent its power, right? That is the thing that enables AI agents to do whatever capabilities to have whatever capabilities you want, right? So in this case, what we have is essentially a fictional cleaning company, right? So I have this imaginary company called Windy City Cleaning Company, and we have calls with potential customers. Those calls are saved as transcripts. And so what this agent can do, it can list all the transcripts that it has available. It can load in any that it needs. It can get the policies of the company, which are stored in a text file. It has a calculator. So we have a client who has a certain number of square foot of their apartment or what have you. And then so you put in the agent puts in square footage, puts in the price per square foot, because LLMs suck at math. You give them a calculator and it gets the price. And then we actually give it the ability to send an email. And this is a real simple email function. So at the end of this, we'll see if this can successfully send an email. It usually works, but we'll see. So we give the agent its functions. And then all this does at the end here is just takes the functions, adds a annotation to them so that the agent knows how to use them, right? Then we have our system message. So we say, you're an administrative assistant for Windy City Cleaning Company. You have access to this database of transcripts. You have the ability to load the transcripts and company policies. And then you can, you're given a task, carry it out with the tools. If you're asked to prepare a quote, reference the policies, and so on and so forth. And so, again, very easy to adapt to whatever purpose you would want to put something like this to. And really, at its heart, an AI agent, the simplest agents are actually very basic but very powerful. Really, what an agent is at its heart is just an LLM call wrapped in a for loop with some tool handling. Obviously, you can take them much more complicated than that, but the simplest ones are, again, nothing more than really a for loop. So here we just we're taking the chat history, and then while we are within the length limit of the conversation, generate a response using the LLM, add that to the chat history, and then if the agent is actually calling one of these tools that we've given it, then we handle that tool call, right? And then lastly here, we also have the ability for the human operator to give input to the agent as it's executing, right? So it's actually a sort of human in the loop system. And we'll go ahead and say, okay, let's prepare an email to John Smith with a quote. I can run that. First thing the agent does, list all the transcripts it has available. Okay, here's John Smith. Let's get our policies. Cleaning price is 25 cents per square foot. Deep cleaning is $100 extra. Furnished apartments are $50 extra. And apartments with cats get a $25 discount because they're cute. It's my fictional company. I can run it however I like. Then the agent decides to call this load transcript tool. Okay, here's the call with John Smith. Reads that in, calculates, okay, from the call we know 1,100 square foot apartment, price per square foot 25 cents, we get the price, and then says, okay, here's the information I'll provide for the quote. Would you like me to proceed with this quote breakdown? I'll say draft and email, but wait to send. Must you send it? Okay. That looks like a good email. Okay. And let's see if this went to my burner email. Sometimes it takes a moment to come in. Anyway, this is an example of what will come through. So, dear John, thank you for your interest in Windy City Cleaning. Here's the quote. And yep, there it is. That's our actual email. So that just kind of gives you an example of the kind of simple but useful systems that you can build with agents right now. Obviously, that's just a very basic demo. But if you're a business owner who's having to like send out many quotes to clients every day, that kind of thing can get tedious. Whereas I was able to automate this with again the entire process of putting together and sending that quote is just typing a few words. And so these kind of simple but powerful systems are actually saving businesses a ton of time and effort even right now. Now, because of that power, like this field has really just taken off like a rocket. So the release of AutoGPT was like right around here. And then, so this is a Google Trends search interest, right? So this is how many people in the world are searching AI agents. As you can see at that time, it's basically nothing. Even in kind of the early days of the field, it takes a while to take off. And then I would say like late 2024 is really when AI agents really kind of go supernova. And so you see releases by like NVIDIA, OpenAI, Meta, Amazon, Google, IBM, Microsoft. I mean, basically every major tech company is getting in on this. We had just major releases at Google and Microsoft's dev conferences just last week. And so pretty much every week you have some major new announcement by these companies. And that is starting to sort of move over into broader corporate America, right? So instead of just the tech companies sort of pushing these products out, now you have a lot of, I would say just about every Fortune 500 company going out and saying like, we need these tools. I mean, working at a Fortune 500 company myself, I can say that is definitely the case for us. And I know it's the case for just about everyone else. So if you're looking to build these kind of agents, there are a lot of great options. If you are a Python programmer, there are tons of frameworks that are good for building agents. I'd say Crew AI, Autogen, which is a Microsoft agent framework, and then it actually had a spinoff called AG2. And then so OpenAI Agents SDK. Google has one called Agent Development Kit, ADK. You got LangGraph by LangChain. Again, I think it is vastly superior to regular LangChain, which everyone knows and some people love. So actually, just last week in the newsletter, I featured, I wrote a feature on kind of the top 7 AI agent or Python agent frameworks. But if you don't know how to code or that's just not really your thing, there are a lot of great options as well. So these sort of low code, no code frameworks, I would definitely look into N8N. That's I would say my favorite one. My co-founder at the newsletter uses that a lot. And he's not a Python guy, doesn't code, but he's able to build some pretty cool stuff just using N8N. Flowise and Langflow are also really good options. I actually learned about Flowise at a demo right here in this room a year and a half ago. And again, Flowise and Langflow are all both really good as well. Now, having a newsletter on AI agents, I get a ton of exposure to kind of what's going on in the field and the latest. And I kind of wanted to highlight 3 of the things that I think are really going to be most impactful in the coming months and years. I mean, really, again, this is a field that moves just so quickly that we talk in terms of like weeks and months as opposed to years and decades. One of the big ones I'm sure you've all heard about is connection protocols, right? So like raise your hand if you've heard of MCP. Yeah, almost every hand in the house. It's so for those who don't know, MCP is Model Context Protocol, which is Anthropic's protocol for connecting agents to tools and agents to data, right? So kind of the big problem that this is trying to solve is everyone's building agents in their own frameworks, their own applications, all of these different formats, and they're not really good at talking to each other. And so if everybody has their own agentic systems, but they can't communicate with each other, then we can't really the agentic web can't happen essentially. And a lot of I'd say the biggest pain point that most people have is not necessarily the capabilities of the agents themselves, it's the integrations, getting these things to actually talk to each other and to talk to talk to data, talk to websites, etc. So Anthropic has MCP, and then Google actually just came out recently with A2A, agent to agent, which, as the name suggests, that's a protocol for connecting agents to each other. And then there's a really cool company that I've worked with called Copilot Kit, and they put out a protocol called UI-AG. And so, as the name suggests, that's connecting agents to user interfaces, right? So that kind of completes that sort of trifecta of protocols that enable agents to talk to other systems and to talk to each other. And once you have that in place, then you really start to build a sort of new internet where these autonomous systems are talking to each other instead of just humans visiting websites. Now, kind of on that subject, obviously, even then, there's still going to be a lot of websites out there that are not very accessible to agentic AI. I think that's going to change over time as these agents become ubiquitous. But the internet as it currently exists and just the sort of world of computer programs in general is very much targeted specifically towards human users, right? Not every program has an API. In fact, most of them don't. And in a lot of cases, the APIs are extremely convoluted and difficult to use, sometimes deliberately. And so the kind of the universal solution here, at least theoretically, is to have an agent that actually carries out its actions by operating through a screen, right? By using a computer, clicking on things, clicking, dragging, typing, etc., just like a human does. And this is a field that I would say has been kind of slow to take off because this just requires a different level of intelligence and sophistication. It's somewhat analogous to kind of like the self-driving car, where yeah, most of the time it works, but if it goes wrong, it really goes wrong. And 99% of the time is just not good enough. But once we get this down, I think that really will have just an incredible amount of power to to give agents the ability to access a lot of systems that are only accessible to humans right now. So computer use agents are really interesting. OpenAI has Operator. Anthropic has Claude Computer Use. Google came out with Mariner. So lots of different cases of major companies kind of betting on this technology, betting on computer use agents as being the future, and I think that they are right about that. Agents as consumers is another big one. So because right now, let's say you want to buy like a coffee table, you go probably on Amazon or go to IKEA, something like that, shop for it, and you're going on there looking at prices, looking at reviews, all these kind of things, comparison shopping. And sometimes that can be kind of a time-consuming and tedious process, especially if it's not something you're particularly interested in. But and so a lot of companies are looking to essentially use agents to automate this process, both kind of traditional agent building companies as well as like the the Amazons of the world. Like they want to make it easier for people to use their services, and so they're actually incorporating kind of agentic agentic shoppers, essentially shopper agents that can go through all the listings on these sites and then look at all these parameters, right? What are the costs? What are the reviews? How many stars does it have? Does it match criteria you want? Like, oh, I want a black coffee table. Okay, is this one black? Those are the kind of things that an agent that an agent can really automate, and that even kind of brings us to a future that a lot of people have been starting to hint at, where advertisers actually advertise to agents, right? So if agents are the consumers, or at least they're sort of like the gatekeepers to the consumers, then you're going to actually get companies start to try to sell things to agents and to advertise with sort of agentic AI in mind. And so I do think that is going to be a major trend, and we're already starting to see companies at the very least discuss that. I think it's in terms of the actual advertising, I think it's just around the corner. Now, the way I stay ahead of this is by researching for my newsletter, and I definitely encourage everyone to check it out. So really what I've tried to do with building AI agents is to kind of cut through a lot of the sort of hype and spam of the AI media, right? I mean, there's so many, I'm sure you see them on LinkedIn and on YouTube and wherever else, just kind of the hype merchants who just use flashy language and all that, and don't really cover don't really cover the more serious aspects of the field. And I'm trying to kind of avoid that and really keep people up to date on really what are the most important things that are going on here. And really, there's been just amazing response from the community. I've got over 3,700 subscribers now. That has been growing very quickly. So every Monday and Thursday, putting out news, useful tools, links to courses, analysis, things like that. Just anything that people need to stay ahead of it. And it's also a very diverse audience. So all the way from founders, CEOs, execs, a very heavy representation of kind of business leaders, but then also a very large contingent of devs, engineers, and so forth as well, who are using this to stay ahead of the kind of technical side of the field. And so again, whether you are kind of just getting started here, not a programmer or whatever, there's plenty of resources there, all the way up to serious engineers. Definitely recommend you check it out. I guarantee you that it will be very valuable to you. The other thing is that that I've kind of been working on, or I should say, more so my friend has been working on. This is a collaboration with him, is something called Orient AI. And what this is this is an agency that's actually bringing agents to small and mid-sized businesses, right? I mean, the big, the Fortune 500 companies of the world, they have no trouble bringing agents on board. They've got, well, actually, I take that back. They have a lot of trouble bringing agents on board, but they are at least doing it, right? They have the PwCs and the Deloittes, bringing these kind of tools in house. They have these huge software engineering teams working on these kind of things. But a lot of small and mid-sized enterprises, they don't have those capabilities, or in a lot of cases they don't even know about them. And so what Orient is trying to do is to really bring these agentic systems to SMBs, and there's been a lot of great response there as well. And so Orient is our partner. Again, this is a very good friend of mine who does Orient. So definitely encourage you to check them out as well. Especially if you have a business, whether it's a startup, small business, mid-sized business, or if you know somebody who does, definitely send them Orient's way. Definitely looking for for people who are interested in automating their operations with these kind of agents. With that, thank you all. Always keep learning, always keep building, and take any questions.
Robotic process automation.
It is an advancement on RPA, and so the reason being, like, RPA was very not dumb in the sense that it was a dumb idea, although it didn't kind of work out really. It was in a lot of cases like wrote, click on this point on the screen, right? So if you have a workflow where you need to process, invoices, okay, click on this point on the invoice. But before LLMs, there was really no intelligent way to figure out, like, okay, what is that point? What if you have another invoice that's structured differently, right? Then you need to click somewhere else, and there's no way to kind of intelligently decide that. And so computer use agents are kind of the fulfillment of the RPA paradigm, where you actually have, ideally, systems that are able to intelligently figure out where to click on a screen, as opposed to trying to use sort of like hard-coded rules or that kind of thing, where that historically has not worked very well. Usually, so this is being done with vision language models. I mean, pretty much all major LLMs are also VLMs now. I don't think there are any major LLMs that don't have vision capabilities at the moment. So I'd say that the line between the two has kind of gotten blurred at this point. Yep.
Yeah. Here.
So CV servers and then can you explain a little more about how that works? Like, if every tool has like an API or some sort of signal that goes out, is it possible for more people to create their own types of protocols, or do companies like Claude just kind of monopolize that? But like a philosophical lens, like, could technically anybody just figure out a way to build a protocol, or is it kind of like created by these larger organizations? Talk about that.
Yeah. So anyone can create a protocol, but protocol adoption tends to be something where once the field is settled on a protocol, it's kind of hard to displace, right? Like USB. Everyone uses USB, because if you don't use USB, your gadgets aren't going to be able to connect to anything, right? Now, there is definitely an advantage to being a company that puts out one of these protocols first, because you can build all of your tech around it, right? And also, to some extent, it's also just bragging rights, like, oh, this is Anthropic's model context protocol. But That said, I mean, it's an open source framework, and so any company can use that, and it doesn't necessarily mean like they're cashing in every time somebody uses MCP. Like they're not. It's not like they're collecting royalties on anything or on it or anything like that. And anyone can build their own MCP server. But there is certainly an advantage to being the company that puts out the framework that everyone adopts. In fact, it was really interesting when Google came out with agent to agent. Their announcement was funny to read because they listed all of their partners in announcing this, and it was literally like they just listed like every Fortune 500 company, and basically the message is like, we're taking this field and nobody else is going to take it, right? So clearly they want that cloud. But yeah, to get to your question, these protocols are like they're monopolizing that connection medium, but they're not. It's not like it's a financial thing necessarily.
Anyone? Anyone has question? No?
What's your opinion on these agents that people like Microsoft are putting in their agent builders?
Oh, agent building agents.
The hyperscalers have low-code frameworks as well. Yeah, they're often called AI agent builders or agent factories. If you're seeing that, but
Well, so are you talking about like the low code frameworks they put out? Yeah. So I mean that kind of gets back to the like when I was talking about like FlowWise, LangFlow, N8N, those are examples. Like those are independent of the hyperscalers, but the hyperscalers are getting in on the game as well, right? So Microsoft has Autogen Studio, for example. Definitely I think that if you're an agent framework at this point, a widely used one, having a low code option is kind of table stakes at this point because as Chris kind of alluded to earlier, like the vast majority of people I think who are going to be building agents in the future are not Python people or programmers. They're they know just enough to be dangerous, as he said. But they're business people or something like that, where they want to build these things, but they don't want to have to learn an entire programming language, and they're using low code frameworks. And so that's the real power of the low code frameworks, and that's why everyone wants to have their own version of this, because if you don't, you're missing out on probably 90% of the market.
Thank you for the presentation. You spoke about Fortune 500 companies using the Deloitte to put agents and stuff like that. Have you, from your vantage point, have you seen like real successes from these initiatives, or are they still more like proof of concept at this point?
Yeah, I mean, so obviously I can't speak to stuff going on in my own company in any kind of detail. Other than to generally say, there are definitely a lot of pain points where we've seen, real transformation from these kind of systems. I would say, speaking more generally, like IBM just claimed that they had, was it $8 billion in savings over the last couple of years with Agentic AI. Now they're pushing Agentic AI as a product, so you got to take that with a grain of salt. But really, I would say, it's a combination. I think kind of the two real models for this are going to be like cross, your normal work process, and you inject AI agents into it. So for example, like the little demo I had, right? Like let's say you're a cleaning company and you're having this agent write and send and revise quotes, right? That can save you a lot of time, but that is introducing agents into a pre-existing process. I think that really, and there's a lot of value to it, I do think, but I think in the long run, the real interesting use cases are going to be actually companies that either rebuild their entire operations around with agentic AI and LLMs in mind, or literally are the entire companies they start as a LLM first company, right, as a startup, and then they build into a giant company. Their processes start with LLMs, and they build and built from the ground up around that. Right? I think that is really what's going to be the future. I mean, the best analog that I would give would be like the steam engine at the Industrial Revolution. Steam engine is the thing that powers it. I think that LLMs and whatever derivatives we make of them, like those are going to be the steam engines of sort of this new industrial revolution. And the factories in the industrial revolution, they were built around the steam engine. Maybe you at first you add steam engines to your current processes, but like that doesn't really work because the existing processes are like one guy in a shed, like hammering on a piece of metal, right? So you really have to build the whole operation from the ground up with mechanization in mind. And I think that's as true of, you might say, like cognitive mechanization as it is of physical mechanization.
Okay.
Nothing?
Thank you.
15 minutes. Can we get you, Chris, and Mary to panel just for a few minutes to take some questions together?
Sure, yeah.
Sure. Yeah. Yeah. In fact,
I'll
like,
run this
okay.
around to people who've got
Yeah.
questions.
In fact, okay.
Or
There-
I can take questions from this panel. There
there-
are pizzas left. If anybody wants anything, you get up, use the restroom, take a drink if you need to. Mary wants to.
There are a few questions from Quentin. He's reading, he's watching from home, so we can start with those two. I think those are perfect. Yeah, for starting. Okay, I'll ask you two. So Quentin, right? is one
I'm
of
already
our-
mic'd up, so why don't you stand next to each
okay,
other?
Yeah. Okay. So Quentin is also helping the chapter to a little bit from Naperville. So anyway, he has this question. First one, actually, this is small. My eyes can't read too well. Okay, so have you read any other models than RAG to support semantic search against proprietary data? So that's the question. Will you be able to?
Me?
For
That sounds like a Chris question.
Yeah.
Oh,
Yeah.
okay, sure.
It's actually, yeah.
Sure.
Okay.
Yes.
Is it mic up?
We've
Is he-
yeah, just about anything you can think of, right? I mean, we came from a vector database background, but we're always looking for ways to improve retrieval. So, we've looked at knowledge graph. The challenge with knowledge graph is if you have data that's very that fits well into a graph format. If I were Spotify and I were dealing with albums, and albums have songs, and songs were written by songwriters, and I've got artists that produce albums, I think it's a nice clean structure, and it lends itself pretty well. When you're dealing with kind of arbitrary knowledge, graph, to me, it's all just metadata, right? So it's just a matter of how do I represent the metadata, and how do I allow myself to query the right information that I'm looking for. With knowledge graph, you tend to have a much more complex pipeline. You tend to have a lot more LLM calls that are being used to extract out the nodes and the edges. And then at query time, again, you're going to have the LLM call that's going to now go and kind of traverse the graph, which can get messy in my experience. Like the graph structure is not a very clean graph structure most of the time. You end up with deduplicating. So to me, it's a matter of, okay, but that doesn't take away from the fact that the metadata is important, and being able to now figure out sort of the traversing the right relationships to get the data that you need. But I think there's different ways to do that. And I haven't seen a huge benefit between say like graph implementations and RAG implementations when done the right way. I think that you always have to look when you sort of see comparisons at the benchmarks, and what are the benchmarks really scoring. So I'm kind of reading between the lines, putting on your profile that says you're a knowledge graph expert, that you're kind of advocating for them, which is cool. And I don't have any problem with knowledge. It just I don't think it's. I personally have not seen the results so drastically improved. And usually I look deeper and see the benchmarks and how they're doing the comparisons are somewhat flawed, in my opinion. We've tried it all. To answer your question, we have tried a whole lot of stuff.
Okay. Yeah, maybe if you read. Yeah, your glasses on.
So that was the first one. The second one. How do non-technical folks assess the quality of their agentic solutions if they do not understand how the content is chunked? Well, I think you do it based on, a lot of times it's LLM is judge, right? Like a lot of times you're creating some sort of ground truth evaluation, like some sort of customized benchmark. One of the things that we do at Vectorize, we generate basically a synthetic benchmark that we use to test how well different retrieval strategies are able to get the content back from the search index based on your unique data. And I think as you start getting into sort of the end-to-end agentic flow, you really want to think. And so we actually just did this for our Blue Cross Blue Shield so they were dealing with an agent that was being used in call centers, and so they wanted to be able to look and say how many, I need to get a prior authorization. What's the process to do this? What's my decision? And so we had to generate for them based on like a few hundred different policy docs, a benchmark to say when this customer asked this question, what should the result be? And then we used LLM as judge to be able to support that. And I think that approach works pretty well. How do non-technical folks assess that? I think the same way, but maybe just a little less automated. Where they
If I could piggyback off that, I mean, I actually think that is the easier task for non-technical people is that understanding how LLMs fail and kind of getting the sense of how to use them, like that takes some time, that takes some experience, that takes some understanding of how the tech works. But I actually think that if you're non-technical, evals are the easier part because you know what you're looking for, right? If you're a subject matter expert in the the business side of things, you may not understand how the LLM is doing what it's doing, but if you understand what good looks like and what bad looks like, then you can build a pretty effective eval, and then you hand it off to LLM as judge. Then you have an LLM deciding if it's correct, but you have the ability to vet that system and make sure that its judgments actually concur with yours, right?
And on LinkedIn, he sort of says these two things. Although I kind of want to steal your question. Michael Cunningham, when you say most major LLM have VLM capabilities, do you mean that the apps that people are using or the underlying? In most experience, Google DeepMind Gemini supports multimodal content, but this is done through an agent that redraws content to different models based on the format.
I actually did not know that. I know that the OpenAI models are natively multimodal, but I didn't know that Gemini is Gemini not multimodal.
It's multimodal. Yeah, it is.
Same.
Yeah.
I mean, everybody.
Okay.
Native implementation, so that true. From an outsider, I think it seems like a very like fine distinction between those things, but
Certainly all the APIs are multimodal in the sense that they have handling for visual inputs.
Okay, and then the next one is on MCP. So out of different agentic frameworks you presented to Michael, which ones are supporting MCP as a standard?
I believe all. So yeah, I believe all of them are. I mean, because all of the those are kind of like the main highly maintained frameworks, and everyone immediately kind of went all in on MCP. It's incredible how quickly it sort of went viral, and then everyone had their own MCP server even if they didn't need one. So all of those frameworks, I know a couple of them specifically have it. The others I haven't specifically heard them have MCP announcements, but I probably wasn't checking. I mean, I'm sure they do. Like some of the more obscure frameworks, maybe not, but certainly any of the major ones, any framework worth its salt at this point has MCP integration.
That's all. Oh, it's fine. Linked it. Oh, yeah, I didn't, but this one from YouTube. Yeah, maybe one more.
Okay, that's one. So larger context window help with generic summaries of large documents, but do not necessarily process well with extracting specific answers from it. That's true. I don't disagree with that. Yeah. I mean, I think when you start loading them up with loading a context window up with a lot of dots, it's just it's hard for it to connect the dots between all the content. I completely agree with that. I don't think anything bad.
Yep.
100% agree.
Okay.
No disagreement here.
And that's all.
That's all.
That's all
Okay.
from the YouTube.
Yeah, good questions,
questions.
Quentin. Thanks for
Yeah.
adding us. Glad you were able
That's
to
right.
get here.
Yeah.
Thanks, Quentin.
Any other questions?
Yeah, like questions. Yeah. No? Yeah, good. Oh, one.
What are your favorite agent frameworks? I already asked you, but what about
Agent
the
framework?
panel?
Not Autogen. Maybe I shouldn't have recommended. I didn't have the greatest experience. Granted, that was like in the early days, so I do think that they've made it better since then. Crew's pretty neat. Yeah, I would say if you had to start with one, I would probably start with Crew. But in fact, almost all the agentic stuff I do now is I have my own setups. And I think that's been a lot of people's experience is that frameworks are great for like prototyping, but if you're really trying to build, complex systems, they are too capable and not capable enough at the same time, and so it's usually a good idea to just build your own at the end of the day.
Well, I guess for me, I'm actually more interested into applying event streaming type of techniques to agent framework. And today, actually, Stream Native, they are the ones that maintain the Apache Pulsar, and they are looking in. And actually, they issue or announce an agent engine too. That's actually making use of Kafka underneath. So a bit kind of lower level that allows you for more fine-grained type of communication between different agents. So I'm looking into that. I wouldn't say it's good. It just came out, and I like to kind of do more research on that as well and doing some experiments. So, how about you? Yeah, did you already?
Already.
Okay. Okay. Cool. Thank you. Anyone else? Questions? I guess we can still hang around for a little bit and chat to folks. Oh yeah, in terms of announcement, I just wanted to invite folks, if you're interested in doing talks or, you have companies or your own company will be, able to sponsor us for any future meetups. We are all open to you too for any help, because as such, we're a volunteer run organization. So we can always be making use of your help too. So yeah, so let us know. Let one of us, Jonathan, myself, Eric, Jenny, and also there. So yeah. So thank you. And thank you again too for David for letting us
Look at my laptop.
hear it. And yeah, you want to say a few words too?
I just did it with Microsoft. I guess that needs to be erased. Those is models we can.
I should probably take it.
Let's do.
I'll show everything.
Thank you.
Really hard.
Thank you.
Oops.
Ooh,
Good.
interesting. Thank you. Oh, good. Thank you. Okay, so I guess with that, anybody else would like to have some announcement or something too? Yeah, you're welcome to have a quick share.
Quick. Hey everyone, Jonathan Shirt. I actually also run a meetup group in the North Shore of Chicago out in Highland Park. So if anyone's in North Shore and wants another one of these, feel free to reach out to me. I'll get you connected.
Okay, thank you. All right. Oh yes, Karen Lene is you are the industry champion from 1871. So yeah, thank you.
Hey everybody, my name is Renee. I am the industry champion for the AI Innovation Lab at 1871. We are having an event on June 10th all about building with AI. So thinking about how these agents and AI are changing the way that we do product and the development life cycle. So if you're around June 10th at the Atomic Object, 5:30. Also, you can find me on LinkedIn, or you can find 1871 on LinkedIn. It'll be there. Also, GenAI Collective and a couple of other friends here building AI agents. Our friends that are also sponsoring the event as event partners. So please come out and support the community, and look forward to seeing you there.
Great. Thank you. Thank you. Thank you. Great. We all good? Yes, good. Okay, yeah. So thank you again for coming, and come again, and stay in touch. Yeah, thank you. So, thank you.